Let's solve this differential equation. The first thing that you should notice when you look at it is that it is very, very similar to the ideal form of a differential equation, which is this. And from this we can find the integrating factor, which will then allow us to integrate the equation and solve it very easily. First, let's get this in this form. So this equation in this form. We have already our y prime, that's simply dy dx. However, we only have to put y tangent x on the left side of the equation. And actually, we have already transformed this into this form. So to find the integrating factor, we simply take e to the power of the integral of p of x. And p of x is minus tangent x dx. The integral of tangent x, you can watch this in one of my other videos, is, since tangent x is sine over cosine, we use substitution to eliminate the sine, and so we're left with 1 over cosine, and the integral of 1 over cosine is ln cosine x. And because it's minus ln cosine x, the integrating factor simply becomes cosine x, because e to the power of ln cosine x is equal to cosine x, right? E to the power of ln of anything, the e and ln cancel out, and you're left with just the anything, which is the cosine x that we have here. Now we multiplied the whole equation by the integrating factor cosine x, and that will tremendously help us. Tangent of x is sine over cosine, and because we're multiplying sine over cosine by cosine, the cosine is eliminated and we're only left with sine. So it's in fact minus sine x y is equal to cosine of x. Now this here on the left side is, without the equal sign, is the result of the chain rule, and chain rule in the derivative sense. This is our first, this is the derivative of the second, then this is the derivative of the second, and this is the first. So you can rewrite this as derivative of cosine x times y, right? And if you were to do this, you get first times derivative of the second plus second, because the derivative of cosine x is minus sine x, times second is equal to cosine x. Now, if we were to take the integral of both sides and put this dx over here, you would be able to transform this equation into y cosine x, because the integral of the derivative of something is simply the something. And I just put the y on the side so that it's not confusing you whether the y is within the brackets or not. And the integral of cosine x is of course sine x, and don't forget the c. Now we need to get rid of the c in order to solve the differential equation, and that we do by making use of the information. So y is equal to 1 when x is equal to 0. So y is equal to 1 when x is equal to 0, and again x is equal to 0. Cosine of 0 is of course 1, so we are basically left with c equaling 1. And so c is equal to 1. Using this information, we have to put the c in here, and then we transform what we're left with into our answer. It's going to be in here. Ta-da! And that is going to be y cosine x is equal to sine x plus 1. But we're not just done yet, because what we have to be left with is y is equal to something. And so in order to transform this into y is equal to something, notice I now have to write below the golden ta-da box, y is equal to tangent of x, because sine of x over cosine of x is tangent of x, plus 1 over cosine of x is secant, and this squeezed in here is your answer, that. And if you were to take the derivative of this, you would find that it looks like this.